Ever feel like you're just drowning in data trying to find that one crucial bit of information?
Well, definitely. It's a common problem.
Well, today on the deep dive, we're going to tackle that. We take the sources you've shared with us and really boil them down.
Get you right to the core insights quickly so you feel properly informed without spending hours doing it.
Exactly. And today our focus is on, well, a really fundamental skill, especially if you're into security or data analysis.
SQL filters.
Yeah.
Using filters in SQL queries. You shared a great article with practical examples, mainly in a security context.
Right, that one. And also some reference material, kind of laying out the basic SQL keywords and concepts.
Yeah, the building blocks.
So our mission today, we want to give you a really clear handle on how these SQL filters work, why they're so important, especially for cybersecurity folks.
And hopefully do it without making your head spin with too much jargon.
Let's try. Okay, first example. This comes from that Apply Filters to SQL Queries exemplar source. It's about finding failed login attempts that happen after hours.
Right. So imagine you're a security analyst. You're thinking, okay, what's happening outside of normal 9 to 5?
Yeah.
That's often where suspicious activity might pop up.
Makes sense. So the query they used was select from login attempts, where login time 1800 and success is sus.
Okay, let's break that down a bit. Select just means grab all the columns, all the data.
From the login attempts table. Got it.
Then the where clause. That's the key part for filtering.
Right, where. And here it has two conditions linked by and D.
Yep. And D means both conditions need to be met for a row to show up in the results.
So condition 1,
Yeah.
login time 1800. That's filtering for logins after 6 p.m.
Correct. After standard business hours, essentially.
And condition 2, success equals false.
That seems straightforward.
Yeah, just looking for the login attempts that didn't work. Failed attempts.
So putting it together with and D, you only get the failed login attempts that happened after 6 p.m.
Precisely. It narrows it down really effectively.
And the output in the source shows this clearly. You see, like, Apatow trying from Canada at 8:27 p.m. failed. And Poishing from the U.S. around 7:58 p.m. also failed.
And Tisha from Mexico just before 7 p.m. success equals 0, so false again.
It really highlights how you can quickly pull out potentially risky events. Failed logins after hours are definitely something to look into.
You can instantly see the value for, a security team. Instead of reading every sort of log entry, boom, focus right in.
That speed is critical when you might be dealing with an actual incident.
Okay, example number 2. This one is about getting login attempts, but for specific dates.
Right. The scenario here is maybe something weird happened on May 9th, 2022.
So you want to see the logins for that day?
But maybe also check the day before, May 8th, just to see if there was any related activity leading up to it. Provides context.
Good point. So the query this time is select from login attempts, where login date 2022 issues 0509 or login date equals 2022 2508.
Okay, so again, select from the same table.
But the where clause is different. It uses or this time, not and.
Exactly. And or is crucial here. It means a record gets included if either the first condition is true, login date equals 2022 0509, or the second condition is true, login date is 2022 0508.
Ah, so it broadens the search. It doesn't need both, just one or the other.
Right. And D narrows or expands.
Makes sense. And the output reflects that. We see Raphael failed from Canada early on the 9th. Then Duckut failed from the USA later on the 9th. But also, the same Duckut failed early on the 8th.
So it pulls in records from both dates, exactly as we asked it to with the OR. It's efficient for gathering related data across slightly different criteria.
Cool. Okay, third example from the logs. Getting attempts from outside Mexico.
Yeah, the thinking here is maybe the company's primarily based in Mexico.
So logins from other countries might be unusual, potentially suspicious.
Could be. It depends on the organization, but it's a common check, flagging unexpected geographic locations.
Gotcha. The query, select from login attempts where not a country like Mex%.
Same start, select from login attempts. But the where clause is interesting now. Okay.
Yeah, we've got not and then like. Let's unpack like Mex% first. What's that doing?
So like is used for pattern matching. And the percent sign is a wild card. It means any sequence of 0 or more characters.
So like Mex% means starts with Mex.
Exactly. It would match Mex or Mexico or even Mexican. That was in the data. It's flexible.
Okay. But then there's the not right before it.
And not just flips the condition. So where not country like Mex% means find all the renews where the country does not start with Mex.
Ah, so it excludes Mexico and keeps everything else.
Precisely.
And the output shows that.
Yeah.
Raphael from Cannes, Apatow from Cannes, Decode from USA, no Mexico entries.
It's a really powerful combo, not with like, for excluding things based on patterns. Very useful.
And the reference guide you mentioned also listed another wildcard, the underscore.
Right. Percent is for any number of characters, is for exactly one character. Good for more precise patterns, though we didn't see it in these specific examples.
Okay, let's switch tables now. The examples move to an employees table.
Yep, showing these filters work on different kinds of data, not just security logs. Useful for general IT tasks, too.
First up, finding employees in the marketing department who are also in the East building, maybe for, pushing a software update to their machines.
Exactly. A targeted update. You need to know who and where.
The query. Select from employees where department, marketing, and office East %.
So now we're working with the employees table.
And we're back to using ND in the where clause. 2 conditions again.
That's right. First, department marketing. Pretty simple. Just find the marketing folks.
And second, office East %. So using again.
Yeah, because the office might be East 170 or East 200A or something.
Yeah.
East % catches anything starting with East.
Smart. And the output shows people like Larson, Jada Rosa, Faf Bautist, all listed as marketing.
And their offices are East 170, East 195, East 267. Fits both conditions.
So an andier to down perfectly.
Just the employees meeting both criteria. Very precise.
Next employees example. Find people in finance or sales? Different update, different target group?
Right. Shows how easily you can adjust the SQL to pull different sets of people based on changing needs.
The query. Select from employees where department, finance, or department sales.
Still the employees table. And notice, we're using or again.
Just like with the dates earlier. So it should pull anyone who is in finance or anyone who is in sales.
Correct. If they're in finance, they're in. If they're in sales, they're in. If, hypothetically, someone was in both somehow, they'd also be in.
Okay. The output listed shows Skillmore, Jaffrey, Abernard, all from finance. It doesn't show any sales examples in that snippet, but the logic holds.
Exactly. The or includes everyone matching at least one of the conditions. Good contrast to the AND example we just saw.
Definitely clarifies the difference. Okay, last one from the employees table. Find everyone not in IT.
Another common scenario. Maybe there's a communication or update specifically for non-IT staff.
The query is select from employees where not department information technology.
There's that not operator again.
This time it's simpler, though. Not department information technology.
Yeah, just a direct exclusion. Find everyone whose department is not exactly information technology.
And the output confirms it. Larson is marketing, Bomarino is marketing, Tisha is human resources. None of them are IT.
Perfect use of not for simple exclusion.
So across all those examples using both tables, we've seen AIN and D or not and with the % wildcard in action.
Absolutely. The source article did a good job summarizing how these operators are used for effective filtering.
And that reference guide you provided earlier, it sort of defines all these key pieces, right?
Exactly. It lists select, from, where, the logical operators, and, or not, the pattern match are like, with its wildcards % and A.
And the comparison stuff too, like equals, greater than A, less than A, and not equals, which can be A.
Yeah, it's like the toolkit. The examples show you how to use the tools defined in the reference. They fit together nicely.
We also had those excerpts from the Tools of the Trade, Linux and SQL Module 4. They seem to really emphasize that learning these filtering skills is crucial.
Very much so. Especially for security pros who need to analyze logs, which often contain numbers, dates, times, all things you can filter on.
That source also mentioned those comparison operators again and the not equal ones.
And it brought up between as well, which is super handy for ranges.
Ah, right. Like filtering for dates within a specific period.
Exactly. The example given was something like where hire date between 2002-01-01 and 2003-01-01.
And you mentioned between is inclusive, so it includes the start and end dates.
That's typically how it works, yes. Unlike just using M, which excludes the boundary value, or which includes it. Details matter.
So wrapping it all up, the main takeaway seems to be that SQL filtering is, well, incredibly powerful.
It's versatile. It lets you pull exactly the information you need from potentially huge databases. Essential for security, IT, data analysis, lots of areas.
So this ability to filter data with SQL, it really hits the nail on the head for what you wanted, right? Getting key information quickly and thoroughly.
These examples, drawn from the sources you provided, they really show practical ways to use these techniques. Pinpointing weird logins, finding specific user groups. It saves so much time.
It really makes you think, doesn't it? You know, looking at your own data, whatever field you're in, how could you use these filters?
What specific questions could you answer more efficiently?
Definitely food for thought.
And maybe final thought to leave you with. We all know data is just growing and growing, right? Exploding.
Seems like it never stops.
So being able to cut through that noise to filter precisely, that skill is only going to become more valuable. Makes you wonder, what other hidden insights are just waiting to be found if you apply the right filters?